Word. Share screen. Sorry about that, guys. I'll do that first little overview real quick, just so we have a recording of it. So we're going to do decimals. Decimals can be presented with mats, strips, and units. Again, blocks, mats, strips, and units, and or money we can represent decimals for. If we wanted to do 2375, we could do it as 2 tens, 3 loonies, 7 dimes, and 5 pennies. Okay, sorry. So now here, let's go back to the rule we were just talking about. Anything with an exponent of 0 is 1. Okay. Anything with a negative exponent can be represented as a fraction. So for instance, if we had a to the negative 1, that would be 1 to the a, and this little n here would be a positive 1. You can see it switches. So if it was a to the negative 2, it'd be 1 over a to the 2. If it was a to the negative 3, it'd be 1 over a to the 3. Now, the reason we're doing that is because we're dealing with decimals. We're dealing on the right-hand side of the decimal place, right? We're talking about tenths, hundredths, thousandths. I know I said it kind of weird like that, but I want to make sure there's the THS at the end. So something we can do is we can then express, for instance, 234.72. We can represent this in expanded exponential form. So what this means, for instance, like the 200 in here, if we were to do that with money, it would be 2 $100 bills. So we can do that. But we can represent 100 because we want these all to be base 10, base 10, base 10, base 10, base 10, all the way across. So 100 can be represented as 10 to the 2, right? Because that means it doesn't mean 10 times 2, it means 10 times 10, which is 100. Or another way to look at it, the 2 represents the number of zeros on the end of it, right? So that 2 times 10 to the 2 is our 200. Our 30 can be represented by 3 times 10 to the 1, right? Because 10 to the 1 is just still 10. Now here's where we're talking about why we have to have the rule with 0. Our 4 is 4 times 10 to the 0. So this 10 to the 0, we realize anything to the exponent 0 is 1. So technically that is 4 times 1. And then we're going now to the decimal place over here. So tenths, right? So 1 times 10 to the negative 1, that's going to be 1 over 10 to the 1, like 1/10. And then the 2 is going to be our hundredths because it's going to be 1 over 10 to the positive 2. Okay. You have to understand that sometimes you're going to have to write numbers in expanded form. It's a very specific situation. You'll see as we go along here. Okay. What about this one? 30.0012. Oh, sorry, 30 decimal. I guess I should actually use the proper terminology. I say point all the time, but it's actually decimal. 30.0012. We want to write this in expanded form. So we have to include all the zeros that are in there. We can't ignore them. So the 30, the 3 at the beginning is going to be 3 times 10 to the 1. Well, here's the whole thing. So 3 times 10 to the 1, because that's our 30. 0 times 10 to the 0, because that's 10 to the 0 is 1, but 0 times 1 is still 0. That's the 0 right in front of the decimal on the left-hand side. 0 times 10 to the negative 1, that's the 10th spot. 0 times 10 to the negative 2, that's the hundredths spot. 1 times 10 to the negative 3, that's the thousandths. And then the 2 at the end, 2 times 10 to the negative 4th is the 10,000ths spot. Do you guys remember? Hopefully you guys all remember your placement. If not, if you're struggling with it and you're still like, oh, I can't remember decimal places like that. If you look in the book, they give you a little bit bigger example, like a little more time to do that if you want. Multiplying and dividing by powers of 10. Now, before I put this one up here, does anybody remember the way they were taught to multiply and divide by 10, the really, really fast way?
Add a 0 at the end, or take away a 0.
Okay, so what you're talking about is you're basically, it's adding the 0, taking away the 0. You're basically moving the decimal place, right?
Yeah.
You're moving it left or right because that will either add zeros or take away zeros. Okay, good, thank you. So that's kind of the way a lot of people remembered how to do this, right? So oops, let me get back to the actual thing here. So if r is a positive integer, you multiply the decimal by 10 to the r, or basically move the decimal r places to the right if it's positive, right? If it's negative, you're going the other direction, okay? Or dividing by. You'll see in a sec what I'm talking about. Those are the rules there, but the examples make way more sense. Okay, so let's look at the first one here. So we have 10 to the 3, right? So what is 10 to the 3? 10 times 10 times 10, or 1 with 3 zeros after it. And we're going to multiply it by 253.26. Okay, so based on Callie's rule, or Kaylee, sorry, no, what, I said it wrong. How do you say it again? Remind me.
You said it right the first time.
Callie. Okay, so she got to go with my gut instinct. Callie said you move it based on adding zeros or subtracting zeros. So here we go. If we have 10 to the 3, that's 1,000. That has 3 zeros. So we're going to move this decimal right here 3 to the right because the number is getting bigger, right? So if we move it 3 to the right, you can see, yep, we move it 3 to the right. There's a comma in there because we normally use commas to break up thousands. Move it 3 to the right, 1, 2, 3, and we have to add that extra zero that she was talking about. Okay. Does this look familiar, guys? Use your thumbs up or thumbs down if it looks familiar. I don't even know if there's a thumbs down. 1, 2, 3, 4, 5, 6, 7, 8. Oh, here they come. Oh, there's a lot of thumbs on the screen. Good thing they don't have the bird on this one. I might be getting a lot of those if I ever ask a question, eh? Okay, so now let's go the other way. Now what we got is we got 253.26, and we're going to divide by 1,000. So now our decimal is going to go the other direction. It's going to go to the left. The number is going to get smaller. And since there's 3 zeros, right, we move it 3 spots. So we move it 1, 2, 3. So it's going to be in front of the 2. Now, here comes good math. Do you see that 0 in front of that decimal? Do you need to put it in there?
No.
You don't, but should you?
Yeah.
Yeah, right. It's always good math to put that 0 in there because that really indicates what we're working through here. Okay, it's good habit. Get your students to do it so they can all be mathematicians and be math teachers someday. Okay, C. This one's 100 times 34 point decimal 764. Yeah, I see a point all the time. Oh. So there's 2 zeros here. You're going to get a bigger number, so you're going to move the decimal 2 to the right. So you end up with 3,476.4. There you go. Okay. Now, we talked about natural numbers, remember, which are counting numbers, 1, 2, 3. Then we add whole numbers, 0, 1, 2, 3, and keep going up. Then we added integers, all the negatives and all the positives. Now we want it, we've talked about it before, we want to talk about rational numbers. Okay, rational numbers, and if you remember, anything that can be expressed as a fraction, remember this A over B. The only thing is B cannot be 0, because remember, you can't divide by 0. It's undefined, doesn't work. But the key thing here for rational numbers is they have to be represented by terminating decimals. Okay, so they can either be expressed as a fraction or a terminating decimal. And when I'm talking about a decimal that just goes on forever. For instance, pi, right? 3.14, but that goes on forever, right? That cannot be represented as a fraction. It's non-terminating, so it is not a rational number. Okay, but there's some weird ones out there. Well, here, never mind. They're coming up right away, so we'll talk about them. Okay, now here's a question for you. Can you take a decimal and convert it to a fraction? Does anybody remember how to do this? And I ask people this all the time, and don't feel bad, because a lot of people go, what you talking about?
Multiply by 100.
Okay, if you have a decimal, that if you multiply it by 100, that will turn it into a percent. I want to talk about turning that decimal, so for instance 0.028, and I want to change that to a fraction. Okay.
Is it 28 over 1,000?
Okay. So you remember, but not everybody will. So give me 1 sec here. Let me stop sharing that. Let me throw up my smart board here. Give me 1 sec. We're going to do a couple of these because this is honestly, this is one of those things that I need to take a sidestep and make sure you understand this. Okay, I got my smart board up there. Okay. So we'll do some easy ones to start just so you can see the pattern. So for instance, if I give you, hang on, let me get my pen working here properly. Come here, get up here. There we go. So if I give you something like 0.5, right? We know right away that the fraction is a half, right? We know that because that's so common. But here's what you do. You take whatever number is to the right of the decimal, or take whatever the decimal number is and completely ignore it for a minute. So I have 0.5. So I completely ignore it, I have a 5. So I put that in the numerator. Okay, draw your line because now we're going to deal with the denominator. And here, what you do is you put a 1. Okay, now, how many decimal places did we have here?
1.
So you add 1 0. Okay, if there was 2 decimal places there, you would add 2 0. If there was 3 decimal places, you would add 3 zeros. Now, can we reduce this fraction?
Yes.
Both are divisible by 5, so we end up with what?
1/2.
1/2. Okay. Is this coming back to some of you?
Yep, absolutely.
And some of you, honestly, this might be the first time you're seeing it. Okay. 0.25. Okay. So what you do, ignore the decimal and put that number on in the numerator. So 25. Put your line and put a 1 there. Okay. Now, how many decimal places did we move it? How many?
2.
So you add 2 zeros. Okay. And now we can reduce this. Both of them are divisible by 25. So we end up with 1/4. Okay. We'll do one more and then we'll actually do the example that's in the book there. So 0.125. So we got 3 decimal places. Okay. So we go here, ignore the decimals, put that in the numerator, 125. Put a 1 there, and you count the decimal places. How many decimal places? You're just gonna make me keep drawing over and over again until somebody answers, eh?
3.
Hey, there we go. So we're gonna add 3 zeros. And now we can reduce this. 125 goes into 1,000. What is it? 8 times? 1/8, is that right? Yeah, 8 times. Okay. Does that honestly, does that make sense to most of you? Well, hopefully it does. Okay. Now let's do the example that's in the actual book. Let me switch screens here. Okay, give me 1 sec here. Stop sharing. Oh, where's my shares? Oh, share screen. Oh, it would help if I put it up. Give me a sec. Sorry. This one here. Share screen. There we go. Okay, so let's go back to 0.28. Now, it's interesting the way they teach this. And again, like I said, sometimes the way you were taught or the way, you know, in this case, the book kind of shows you might be a little confusing. But what I would do, honestly, is I would do it the method that I just told you. So if you have here, you get rid of the decimal and you have 28, right? And you put it over 1. And then how many decimal places are there? There's 3, right? So you would end up with 28 over 1,000 and then reduce it. Now, let's take a look at this. This is how they break it down. It's kind of interesting. Oh, sorry. So what they do here is they take the 0.25 0.028, and they times both the top and the bottom by 1,000. Basically, is that what we were kind of doing? Yeah, I was just doing it in a simpler way of doing it, right? So there's my 28 on the top. I have my 10 to the 3 on the bottom, which is technically 1,000, right? Now, what they do is they then go down and they break prime factorization. I really don't like that because you should be able to look at numbers and figure out how to reduce stuff. So for instance, if you look at this and I got 28 over 1,000, right? I know right away it would be divisible by 2 because one ends in 8, one's ends in 0. But then I can also see, oh yeah, I can take 1,000, I can divide it by 4. And I know my times table, so I know 28 is also divisible by 4. So I get my 7 over 250, right? Sometimes, like I said, the book does a more complicated way. I prefer the easier, straightforward method for doing math, right? I sometimes refer to it as the KISS method. And I don't know if you've ever heard that, right? Keep it simple, sweetie. I don't know if you've ever heard that, KISS. And it often works really well when you're doing math. Do the simplest method possible. Okay. So sometimes you will get in math, remember, because what we said before, rational numbers are terminating decimals like these ones here. But sometimes you're going to get ones that are non-terminating. Okay. These ones go on forever. They go on to infinity. But the difference is they repeat. There's a pattern to them. Some of the most common ones are 0.3333333, right? And 0.66666 all the way, right? Those are two really, really common ones that repeat, right, but never end. So for instance, we have 0.123 is a repeating decimal with a length of 2, because if you look at the line, it's not over the 1, it's only over the 2, 3, right? So this is what the pattern would be: 0.12323232323, right? But there is a pattern there. Okay. So when we talk about rational numbers, right? A rational number can be written as a fraction. That's always in play, but either as either a terminating decimal or a repeating decimal. So for instance, like the ones we just did here, let me back up here again. These ones here, these are terminating, right? 0.028. That's terminating, so that is a rational number. But one that repeats and goes on forever, right? A good example is 0.3 repeater. Does anybody know what 0.3 repeater is as a fraction? It's a super common one.
One third.
1/3. So 0.3 repeater is 1/3, right? 0.6 repeater is
2/3.
2/3. Those ones are the most common. And if anybody's done any baking, right? Measuring cups, right? 1/3 of a cup, right? Remember, you got full cups, half cups, quarter cups, eighth cups. You also, most of the time, will have 1/3 of a cup, right? So 1/3 is a rational number. It can be expressed as a fraction, but it is also a repeating, non-terminating decimal. Okay, that makes sense? Repeating, non-terminating decimal. Okay, I'm just talking, I'm basically trying to get you to understand what rational numbers and what they can be portrayed as. Oh yeah, there we go. Somebody's putting it in. I should always, I need to have chat up all the time, but I sometimes, oh, sorry, go ahead.
Why non-terminating?
Sorry, what was that?
Why non-terminating?
Because 0.3 repeater never terminates. It's non-terminating. It goes on forever to infinity, right? So that's what non-terminating means. Because we can have numbers that never ever terminate, or that are non-terminating, but they do not repeat, right? And that is known as pi, right? 3.14. And that is not a rational number. That is a, somebody? Irrational, right? I don't know if you were ever growing up and your parents told you stop being irrational, right? It was a math term. They were just trying to be really mathy, right? That's really what they were trying to do. right? So something that doesn't terminate but doesn't repeat is not a rational number. It's a right? Irrational, sorry. Okay, but what we wanted to talk about was rationals. Okay, and oops. Oh, sorry. Let's get back to the screen here. Every terminating or repeating decimal represents a rational number. So what I'm talking about, if it terminates, if it stops, right? That terminating that terminating decimal can be expressed as a fraction. You know it's a rational right away. Okay. So now what we can do is we can talk about, and you always got to talk about value of decimals, right? You can give lists, you can give numbers to kids and say, okay, put these in order from smallest to largest or largest to smallest. It doesn't matter. So decimals always freak people out because, you know, you could have well, here, let's look at this one here. This one here, a lot of people will go, oh, the one on the right, the 2.3570946, it's a bigger number because there's more decimals, right? That's a common response to that one. But what we want to know is which one's the smaller one. So what we do is we look at the values. So we start, both of them start with a 2. Yes? Awesome. Then they go decimal 3, decimal 3. So far, so good. Decimal, so 2.35, 2.35. So far, they're the same. 2.357, 2.357. Perfect. They're all the same. Now, here comes the first discrepancy. 2.3571 and 2.3570. Right? So there's a discrepancy there in what we're looking at. Okay. So then what we can do is we can look at we look at that number and we decide which one's bigger, which one is smaller, right? That's what we're looking at in this case. So here, let me get back to this here. Click on this. Okay, so the first digits from the left are 1. So the first different ones are 1 and 0. Here's the deal. Which one's bigger, the 1 or the 0? Well, the 1 is bigger, isn't it? The 0 is the last one. So do we even care about the 946 at all? No, because we're just ordering them from smallest to largest. So in this case, right, this one here, missing the decimal out of the page here, 2.3570946 is smaller, even though it has more decimal places. It's still smaller than the other number. Does that make sense? That you don't need all those numbers? You just got to find the difference between, or find the difference between them. Yeah. Thumbs up. Yeah. 2 thumbs up. If you guys use thumbs up, then it's kind of a quick. I think it's called a temperature check when you do like a quick scan of what people know or don't know. You'll do that. You'll do that as a teacher all the time in school. Okay. Oh yeah, here. Numbers represented by non-terminating. So this goes on forever, and there's no repetition to them, are called irrational numbers. I already said this already, right? So those are things like pi, or the square root of 2. If you actually do the square root of 2 on your handy dandy calculator, square root of 2, you get 1.414213. It just gets a whole bunch of numbers. There's no pattern there. They go on forever. That's also an irrational number. Square root of 3 goes on forever, no pattern. That's also an irrational number. Okay, now here's the overall overarching thing. Natural numbers, or the counting ones, whole numbers, integers, rationals, and irrationals all make up what set of numbers? And it's right here on the screen. They make up all. Somebody say it, just so we know we're clear. All
real numbers?
All real numbers. Thanks, Sam. They make up all real numbers, right? So natural, whole, integer, rational, irrational, all make up all real numbers, because there is a whole stack of math related to non-real numbers. Get this, imaginary numbers. There is math related to imaginary numbers. Does anybody know what it's called? calculus. You guys ever heard of the term calculus?
Sorry, could you describe it again there, Brian? What was that you just said there?
Which part of it?
Like you just said, you just described calculus. How did you describe it again?
One of the main components in calculus is the square root of -1. I don't know if you've ever seen that. Square root of -1, right? You can't do that. You cannot take the square root of -1. It's impossible. So what they do is they actually assign lowercase I to it, and it's called an imaginary number. So then when you start getting into derivatives and integrals, which is part of calculus, which is a whole different component of it, you're technically outside the normal use of numbers, right? You're not using natural numbers, you're not using rationals, well, you're not using any of that. You're not using any real numbers, you're using imaginary numbers. It's one of the, there's more to it than that, because of course you're still going to use those numbers in calculus, but one of the main pieces is you can actually start doing math with imaginary numbers. It's a whole field of mathematics. So if you ever get the chance and go to university and want to upgrade, that would be like taking Calc 1, Calc 2, Calc 3, and Calc 4. If you're going to do that, you're probably going to teach high school mathematics, which some of you may and some of you may not. It's up to you. Okay. Okay, so now let's do some computations with decimals. Let's round, let's add, let's subtract, let's multiply and divide with decimals. Okay, and what is it, 6 o'clock? Okay, we're right on track. Okay, so rounding, we know how to round already. We talked about this before. You find the decimal place, right? You look to the right of the one you want, and if it's 5 or greater, you round up. If it's 4 or less, you keep it the same, right? Those were the rules. We did those already. Okay, so let's look at one here. So we have 3.6147, right? And we want to round it to the nearest tenth. So first off, you have to know your place value. You have to know where the tenths are. So what number here is the tenths?
6.
The 6. Okay, so the 6 is the one we want to round. So we got to look at one to the right of it. And the number to the right of it is, so consider the digit to the right of the 6. It's a 1. So now, because it's less than, it's 4, 3, 2, 1, or 0, right? We're going to keep the 6 exactly the same and put everything else as zeros. So if you look at this, right, the 1 is going to keep that 6 exactly the same. We can change all those to zeros. And now, do we really need those zeros in there, or can we drop them?
Drop them.
You can drop them, right? So you can drop them right down to 3.6. Okay. And again, you really have to know. So if you were teaching this, let's say you were teaching this to kids, you might have to go with place value first before you even talk about rounding. Because if they don't know where the tenths are, or the hundredths, or the thousandths, or the 10,000ths, right? If they don't know where those places are, they can't round. Okay. And some of you actually may have this on your wall in your classroom. You may have a number chart with place value chart, right? Yeah, there is lots of good games out there, Alice. Very good point. Okay, now here's 2 ways. 2 ways of doing addition. First way, second way, oh yeah. It really depends on what you do. Okay, so adding and subtracting decimals. When you're adding these, especially if it's 3.6 and 1.23, you have different place value, right? You got tenths and you got hundredths. So one of the ways to do this is to convert these to fractions, right? So you could convert them to fractions. You would do like 36 over 10, but that doesn't help us because the next one would be 123 over 100. So you might have to change your fractions so they have common denominators. And some people will really struggle with this. I think a lot of kids would actually struggle with this. You'd have to let me know if any of you learned it this way at one time. So the 123 over 100 is really easy because, right, take the 123, put a 1 there, 2 decimal places because it was the 2, 3. You'd end up with the first one would be 36 over 10, but then you'd have to multiply both by 10 to get to the 100, right? Oh boy. Now you have common denominators. You can add them together, right? And then work backwards and convert it back to a decimal. Okay, that seems like a lot of work, doesn't it? How did you guys learn it? Let me know. Let me answer that question. How did you guys learn how to add decimals? And don't say with a calculator.
Just
First
stack them
way.
on top of each other, make sure they line up.
Okay. I think both of you said it at the same time. You stack them, right? Stack them. So you stack them, right? So 3.6, right? Or 3.6 and then 1 point. And it doesn't matter, remember? The rule that it doesn't matter addition. But why did we add this extra 0 in here at the top?
So
Like
half with addition.
yeah, so it lines up. So then we have everything in the columns. And that's usually useful when you're teaching addition. It's easier if you have everything lined up. You can add as many zeros you want to this, right? Look back here, right? When we did the rounding, 3.6000, we can add as many decimal zeros as we want. It's still 3.6 or decimal 6, sorry. Okay, that honestly, by show of thumbs, is that the way most of you learned how to add? Let me see some thumbs, if that. If not, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's pretty common. Did anybody learn a different way? And don't be afraid to tell me, because I don't know. Some of the ways I don't know about addition.
Maybe a calculator.
Well, oh, cool. And okay, so here's a. Let me get on a little tangent here. Math scores in Manitoba are quite low. I don't know if you guys have read that in the past number of years. Math scores are quite low. And one of the things is they're finding kids cannot do a lot of math like what we're doing right now. They need their calculator to do like 3.6, 3.60 and 1.23. When you teach, you can teach how to do stuff with a calculator, but you still have to teach how to do it manually first. That skill is a requirement in Manitoba before you can actually grab a calculator. So if you're teaching grade 1, you have to show them how to do it old school, right? And then you can show them with the calculator. Okay.
I don't even like to have the calculator in my early grades here because it's so simple math.
But here, and this is just me personally. So I become so reliant on using a calculator, and this is silly. I will sometimes find myself doing really easy addition questions on a calculator. I'll give you like 2 plus 7, like not exactly, but I'll do really simple, and then I'll realize, why am I doing this on a calculator? Because you get so used to using one of those that it becomes kind of ingrained when you do the math.
Yeah,
okay.
I fall into the same trap when correcting some of the students' work.
Yeah.
Really math questions, and I guess it's an easy crutch to hold on to while correcting.
Yeah, you're definitely right on the money with that. Let me answer your other question there too, Eric. I just noticed it there. How would you round 3.649999 to the nearest 10th? Okay, so which position is the 10th on your one that you sent me?
Oh, I know the answer. I just want to be annoying with that one.
Oh, well, it's 3.6. It doesn't change. Right, because you don't care about the 9s. You only look at the 4 value. But I think you knew that already.
It's very tempting to round it to a 7.
Super tempting. But I mean, yeah, that's one of the things when you're teaching rounding, you'll have to really deal with. Okay, now that was addition. So again, the same would apply to subtraction. We don't do any examples here, but the easier way, you could, if you wanted to, create them as fractions. I don't know why, and then stack them and subtract. Okay. Now, what about multiplication? Right. Let me show you the way they do it, and then we'll talk about the most common way. So the way they do it is they break them down to fractions again. So 0.6 would be 6 over 10. 1.03 would be 103 over 100. And then you multiply like you normally would. 6 times 103 and 10 times 100. You end up with, oh, good grief. Oh, sorry. Hang on. I just screwed up my screen here. Sorry. Right. You'd end up with 618 over 1,000, and then move the decimal back. Now, that to me, again, that seems like way more work. I mean, you really have a good understanding of how to convert stuff back and forth, but to me, that seems like a lot of work. Probably the most common way to multiply decimals is which way? Say it again. You guys said it for addition.
Stack.
Stack them. Stack them. Here we go. This is probably the way most of you learned. Okay. So let's put it all down here. You stack them on top of each other. Here we go. You stack them on top of each other and you ignore the decimals. Remember that? You would completely ignore the decimals for the first time. So then what you do, right? You go your 6 times your 3, right? Your 6 times your 0, your 6 times your 1, and then do your 0 times the 3, 0 times the 0, 0 times the 1. You stack them and then you add them, right? But then how did you decide how many decimal places to put in at the end? Well, you just count them from the original question, right? So here, there was 2 decimal places, right? On this here, the points decimal 6, there's 1 decimal places. So you need to move it from the right-hand side going left. You need to move it 3 decimal places. Is that the most show me by thumbs up. Is that the way most of you learned it? Was that way? Stack them, multiply, add them, and then do the decimals? Nobody? No response? No, there's some thumbs. 1, 2, 3, 4. Is there other ways, or some of you use calculators too? Is that another way too?
I was taught to take decimals out for now and then put them in after you.
Yeah, that's what I just said. Here, let me show you again. They're just not taken out on the screen, but that's what I was talking about, like showing. Give me a sec here.
Hey, I have a
Cheers.
question.
Yeah, hang on 1 sec. I'm explaining something to somebody first. Let me put it back up on the board here.
I'm sorry.
No, it's okay. Don't. I know you're excited about math. Right. So for instance, what she was talking about there is if you had right 0.6 times 1.03, right? You would do it like this: 103, right? And 6, right? And then you were talking about doing your multiplication, right? So your 8, your 1, and your 6, right? Then you go up here, like you said, and you count. So then you move your decimal, right? That's what you're talking about, right?
Yeah, that's the way I was taught.
Yeah, and and honestly, that's probably one of it. In reality, you teach the kids simple rules and then do it. And you just do it over and over and over again, like rote memorization, and it just becomes ingrained into their head. Yeah, that's probably like I said, one of the most common ways. Okay, let me stop sharing this, go back to this, and then Alice, and then I'll answer your question, right? Let me just get back up here. Okay, go ahead, Alice.
I don't know why I remember lining up the decimals. Why doesn't it apply here?
You line up the decimals when you're adding or subtracting vertically, right? So for instance, back here when we added, let me go back. We added these ones here. Do you see how our decimals are lined up? Even though it was 3.6, we added that extra 0 in there. So then our decimals line up. That's when you're doing it for addition. You don't normally do it with multiplication because you're basically ignoring them until you actually find the one you want. The one you want.
Okay.
Okay. So I think the next page is they break down the whole rules here. So let's put this up here. So when you multiply 2 decimals, do the following: multiply as with integers, then count the number of digits to the right, and then you finally move the decimal point, the total number of those digits. So basically what we did on the previous page, there is the full written description of that thing. Okay, now let's do some practice because I know you want to, you're just itching to do these questions. Maybe not. Okay, here we go. So 7172, there's a bunch of them there. Lacey, I think I threw up the pages on the website there for you because I know you have the old book. So
yeah, I'll give it a look. Thank you.
Awesome. Okay, so start on those ones and I will be right back. Start on those and then we'll take a break after that. Oh.
Hey Brian, I just got back. These practice questions, is this the first set of practice questions or the second set?
First set, we still haven't done 7.3 and 7.4. We just started them
Okay.
like 5 minutes ago or so.
Yeah, just double checking. I'm gonna get started on them now.
Awesome.
I don't quite understand question 3. I don't understand question 3C.
Which one? 7.1?
Yes.
And what number, sorry, again?
Question 3C.
Hang on a sec. Let me look here. 2.5, 2.6, 2.7, 2.8, 2.9. Okay. So the big lines are decimal 0.1, right? So the big lines. So for instance, if you start at 0.25, move to the big line, that would be 0.26, 27, 28, 29, and 0.3, right? Do you see that first?
Yes.
Okay, so now the middle lines between them is an extra place. So for instance, if the first one was 0.25 and the next big one would be 0.26, the shorter dark line would be 0.255, right? So we start at 0.25 and then we're gonna go short one, big one, short one, big one. So 0.25 and then 0.255, 0. Decimal 26, 0. Decimal 265, 0 decimal 27, 0 decimal 275. So the number we're looking at for C is somewhere between 0 decimal 275 and 0 decimal 28. Well, each one of those tick marks, right, is 75, 76, 77. Like it's that extra decimal place.
Okay, thanks.
You're welcome. Yeah, those are pretty small numbers there to be looking at for.
I have a question.
Which one?
So just for the first one there, writing it in expanded form. So when you write in expanded form there, right where the decimal is, why do you start like let's say the 3 there is 3 times 10 to the power of 0, but after the decimal you don't put 4 times 10 to the power of 0, you just go straight to like 4 times 10 to the power of -1.
Right. Because what happens is the 3 is in the ones spot, right? We actually like ones, but the 4 is not the ones, it's the tenths, right? It automatically starts at the tenths. So when we want our 10, we need it as 1 over 10, right? We don't want it as 1 over 1. It's just in the wording of it. That's why.
Yeah. Okay, I understand.
Good question. Good question.
Why is question 5 2.45? Why is there a decimal in there?
What we're talking about when we did our representations back here, give me a sec. Give me 1 sec. Right? When we talk about our mats, right? That would represent the ones. So in this case, there's 2 of them. So that's why it's 2 decimal, right? Now, if they had given you a picture with those in it, like that extra big one here, base 10 blocks, then you would have written the number differently. But because they only gave you this first one like this, you automatically do 1, and then your decimal is right here between the flat and the strip. So your decimal's right there. That's why.
Okay, thanks.
You're welcome.
What's the difference between expanded form and expanded exponential form?
Expanded form would be, right, hang on, we were just there. Expanded form, this is expanded exponential because it's 10 to the 2. So if you just had it in expanded form, it would be 2 times 100. And this would be 3 times 10. You just don't have the exponents up there. That's the only difference.
Yeah, in the book here, it says any decimal has an expanded form, and then it gives the expanded exponential form.
Yeah. It's just the way they
So I was
represent
wondering.
it, right? Because this comes into, like, you'd probably have to, if you were doing expanded form of decimals, you'd probably have to teach scientific notation too, because it's kind of in that ballpark too.
Okay, thank you.
You're welcome. Time-wise, guys, for those that haven't taken a break, we'll take a 10-minute break. So come back at a little bit later, 22, or you can just keep working on these questions. I mean, you know, I don't need to take breaks because doing math is like a break to me. I don't know if it's like that for you guys too. It's an enjoyment, you know, doing questions. Are you buying any of that?
Okay, great. I'll ask you questions.
Fine, Alice, you can ask me questions. Go ahead.
I'm still having trouble understanding questions like question 7.
Okay. So let's do the first one there. Here, let me switch screens just so you can see what I'm talking about here. What do I need? Oh, sorry. Stop sharing. This one, share that one, and hit share. Okay, that's the one I want. Okay, give me a sec here. Oh! So something like this, which is, what is it? 0.324, okay? Let's convert this to a decimal. So ignore the decimal right off the hop, and you're gonna end up with 324 as the numerator, right? And then we put a 1 here, and then how many decimal places did we go?
3.
So we add 3 zeros. Okay, so now here's the issue. A lot of people see these questions and they go, okay, we need to reduce this fraction. And sometimes it's hard to see patterns. But for instance, if you notice, if this ends in a 4 and this ends with a 0. So first off, is it divisible by 2?
Yes.
Okay, so you don't always have to get your reduced fraction in the first form. So if we divide by 2 and divide by 2, they're talking about doing prime factorization of it, but this is a simple method too. So this would be what, 150, what's that, 162 on the top and 500 on the bottom, right? Now, both of these are even numbers, so could you divide by 2 again?
Yes.
And if you actually look, we're prime factoring it in a different way because we're dividing by 2. It still works, right? What is that? 81 over 250?
Yes.
Okay, now the problem with 81 is it's not an even number anymore. It is divisible by 9. It is divisible by 3. So then you have to look at the 250. Is that divisible by 3? Is that divisible by 9? I don't see any of those in there.
Me neither.
Okay. Now, if you have, do you have your calculator in front of you?
Yes, my phone.
I don't know if it works on your phone because you need the ABC button, right? So if you typed in 81 ABC 250 and then hit equals, if it can reduce it, it'll tell you if it can reduce it one more time. I don't think you can do it on your phone. I think you need an actual calculator for that one.
Yes, I need to get me one. I don't have one.
The ones I recommend, and here I'll put it up on the screen again. You can get them. They're actually probably one of the most inexpensive calculators, but they're probably honestly one of the best. Is these Sharp calculators? They kind of look. It's a standard Sharp calculator. Kind of looks like that. They're only about 15 bucks, but these ones, like you can actually see they show up quite nice on the screen. You can go back and edit stuff. Like they're quite good calculators for about $15. And they're just Sharp calculators.
Okay, thanks.
I have lots. I got about 20 of them here if you want, but
Just throw them over.
I mean, we could always, hey, for those that are here, let's see if any of this brings back memories. Depends on how old you are. Do any of you need to make a phone call? Do you guys remember these at all? This was some of the first phones. They were bag phones.
Yep.
I have a lot of useless technology in my room. Anyways,
Hey, the answer key actually says 81 over 250.
there you go. So that is the lowest it can get then.
Okay, why do they also write 250 equals 2.53? Why do they bother?
2.5, what?
They have 81 over 50 and then they added a semicolon and wrote 250 equals 2 times 5 over 3.
Oh, because they're prime factoring the 1,000 or they're prime factoring the 250. I think. Here, let me look at the answer key here. Let's see what they actually wrote. 7.17b. Give me a sec here. 7.17. Oh yeah. So what they did is, if you actually look at the question, it says, write these decimals as fractions in lowest terms, and then determine the prime factorization of the denominator. You didn't really need to do that in this case. So the 250 breaks down into 2 times 5 to the 3.
I missed the last part. Okay, thanks.
You're welcome. We were breaking. We're coming back, Sam. We're coming back at 22. If you needed one. Some people didn't need one, so.
I just wanted to clarify for the expanded form and expanded exponential. Like, what are you only looking for one from us? Is there one that you want us to stick to, or are we going to need to remember how to do both?
The only difference is, like when I showed that one up on the board, The only difference is instead of having 100, you would have 10 to the 2. If it's 100, that's just expanded form. If it's 100, or if it's 10 to the 2, that's expanded exponential, because there's an exponent. That's the only difference.
Okay, because in the answer key here, they have it in the fractions, like 1/100, 1/1000.
Oh yeah, you could also put it that way too. I'm pretty lenient when it comes to that. All three of those are valid ways of writing it.
Okay.
Right. Go ahead.
Then for the, I think it's question 1B, in the answer key, they didn't have like the four zeros that come before the final decimal places. Do you want us to include that normally?
No, either way is actually fine.
Okay, I just want to double check.
If you don't, here's the deal. If you include those zeros, that works for people that don't realize that the 7 is going to have a negative, I think it's that 1, 2, 3. That 7 is going to have a -4 on it. So if you didn't have those other zeros in front of there, some people might think that that's the first decimal when it's not, because there's 3 zeros there. It just depends. If you understand it, you don't have to put the zeros, right? You can go right to the 7 times 10 to the -4.
Okay. So then if we're writing the expanded version of B, for example, when we have those negative exponents, how would we write it then?
7 times 10 to the -4, or 7/10 to the 4. Either way is fine.
7/10 to the 4.
Right? Because normally the rule is you never leave a negative exponents. It's just one of the rules you learn as you get into high school, right? So you would never leave 7 times 10 to the -4. You would write it as 7 times 1/10 to the 4, right? As a positive. But for this purpose, it doesn't matter, because we're just talking about different place value. That's all we're talking about.
Right, because you wouldn't put the negative in front of the 7 and put like -7 times 1,000 to get to that decimal place.
No, because that's not the negative. It's the fraction part is the negative. The 7 is
Okay.
still a 7.
Got it. Thank you.
You're very welcome. Okay. We got another piece to do here. So I want to make sure I give you enough time again on the next one. I know that it's going to be one of the biggest complaints at the end, that I don't give you enough time to work, but it's because of the length of the class. We really need a longer class and a lab. But let's get on to, well, I'll try to, 7.3, 7.4 is pretty quick anyways, because we've covered a lot of that. So let's do 7.3 and 7.4. Let me pop it back up on the screen here. Okay, that's the one we want. From current slide. Okay, I think that's where we want to be. Okay, proportional reasoning. So, oh, sorry. Our school is so dry. Okay, proportional reasoning is well, here, let's just get into it. Anything that you're dealing with a ratio is basically a fraction. A fraction is a ratio is a fraction. So for instance, if we talk about a ratio of A to B, we're talking about A divided by B, right? Our quotient there. So you can use that with letters, but the main thing we're dealing with here is we're dealing with fractions, because we're also obviously in decimals and stuff. Okay, so express a ratio of 24:16 as a fraction in simplest form. And when they say simplest form, all they're talking about is reduction. Reduce it to its lowest form. Okay, so 24:16 is 24/16. You look for something that's divisible both in the numerator and the denominator. In that case, this would be 8, right? 24 divided by 8 and 16 divided by 8 is 3/2 or 3/2. Most of the times you will not see the second part, 3/2 or the 24:16. You'll see it as a fraction. That is the most common way to write it. Okay. If you have two fractions or ratios, and you want to find out if if they are equal to each other, they're called proportions. So for instance, this is where you would talk about you have 2/4 equals 1/2, right? You take your fraction or your ratio and you reduce it down. Does anybody remember the quick way to do it? To test to see if they're equal? Does somebody remember this from last week?
Cross multiplication.
Say that again.
Cross multiply.
Yeah, cross multiply. So for instance, if you take A and D and multiply them, and you take B and C and multiply them, and you can see right here, if they're equal to each other, then you have an equality or a proportion, right? That's the quick way to do it. You just multiply them and you can see right away. That's also a good way to tell if two numbers or a number is larger than another. Okay, now, the reason we do this, there is a reason, don't worry. The reason we do this is we can get into solving. Some of you might remember this. Solving for the unknown. Well, you do the exact same thing we just did on this page here. You multiply on the diagonal. Basically, it's called cross multiplication. So if you look, what we're going to do is we're going to take the 28 and the 21 and multiply those together. And we're going to take the 49 and the X and multiply those together. So you can see what we get here. Oh, what? Where'd my number go? That's weird. 28 times 21. There's a mistake on this page. What is 28 times 21? 28 times 21. 588.
588.
Yeah, okay. Let's fix that. That's weird. Why did that come out? 588 divided by 49. That's the right answer. Huh, that's weird. You know, I wish people that made stuff properly. It'd be nice. Make my life easier. Hang on. So what did we say here? Let's get rid of this. And this number should be, what'd you say, 588? 588. There we go. That's better. Okay, so the 28 times the 21 gets your 588. And then how do we get rid of the 49? Well, we divide by 49. And you got to give me 1 second because I'm looking at my notes here and I'm going to fix this. So when I teach this next year, I don't know why I didn't fix it last year. Who knows why? So 588. Put a big star on this page so I remember. Fix. Put a big arrow. There we go. You can see there. Make myself some notes. Got to fix it. Okay. Now, do you guys remember that? Yeah. Did any of you, just a side note, ever learn the fabulous Dr. Z method? I'm just wondering. A lot of our kids know it nowadays, so I'm just wondering if anybody has ever been. Okay, good. I'm not telling you then. You don't need to know it. It's just a quick way to do it. This is the proper way. Cross multiplication is the actual proper way to solve all these proportions. Okay, so then what happens is you could say something's proportional to something if it has, so y is equal to x, and you can put a k value in here. And this k value could be anything. It could be just a regular number. It could be a fraction. It could be a decimal. Who cares? But we can say they're proportional to each other. Now, the reason this is introduced in this section is because we're going to get back to this k value later on when we start graphing lines. Y equals mx plus b. Some of you might remember that. Talking about slope, rise over run. Hopefully that this is pre-teaching for another unit. So that k there is going to be what's called our slope, and it's a proportion, and it's called a constant because it doesn't change. Okay, now when you're teaching stuff, a lot of students, and even probably you guys, like younger students, and then you guys, probably want to know, well, why do you do this stuff? Why do we teach this stuff? There has to be some real world example. So let's take a look at this example here coming up. And I've altered it out of the book because the book just did a nasty job of it. So what we have here is we have a tree, okay? We do not know how tall the tree is because most people can't go outside and measure the height of the tree. But what we can do is we can see that, oh, okay, this tree here casts a shadow. So along the bottom here is 20 meters, right? All the way along the bottom here. And what we got to do is we got a stick here. And we know the height of the stick. The stick is 1.75. And it casts a shadow of 2.5 meters. So what we can do is we can actually create a proportion. We can actually figure this out mathematically to figure out the height of the tree without actually having to get out and measure the tree, which we can't do because it's really tall. So what we do is we set up a proportion. So h, the height of the tree, over the height of the stick, right? So the height of the tree over the height of the stick is equal to the length of the shadow of the tree over the length of the shadow of the stick. Okay, so height of the tree over the height of the stick, length of the shadow of the tree over the length of the shadow of the stick. And you can see it's a proportion. And these will work out perfectly because it is a proportion. So how do we solve this? Well, we cross multiply, correct? So h times 2.5 and 20 times 1.75. So let me see if I did the work here. Let me look here. Right there. So we end up with 2.5h equals 20 times 1.75, right? 20 times 1.75 is 35. We got to get h by itself, so we divide both sides by 2.5. So we find out the height of the tree is 14 meters. Okay. Now, just think about this for a sec. This example, could you do this with a class outside in the summer? Or not in, well, in the spring. Could you do it in the spring?
What? Yes.
You could actually, one of the most common ones, and I actually took my grade 9 class out one time, and we measured the height of the flagpole in front of our school based on just shadows. And it works really well. Like it's fun because it's a hands-on practical thing to dealing with math. Okay. So there's lots of applications when if you really want to look for them, of changing stuff over to real world examples, because a lot of students always ask that, well, when am I going to use this in the real world? Now, you know what I said to one of my, and you have to know your students when you say this. So one of my students asked me one day, they said, Mr. B, when am I going to use this in the real world? So I turned to them and said, you won't, but one of the smart kids in the class might. So you really have to know your students if you're going to throw a joke out like that. And of course they laughed and they thought it was quite funny. But again, students are always looking for real world examples. So the more you can find as a teacher, the more they're going to learn, the better they're going to learn. Okay, let's get on to percentage. Percent. We got a couple pages here. We got a compound interest in here too. So percent means out of
100.
Yeah, that's all it means.
Right.
Don't get fooled by anything. Percent just means out of 100, out of 100, out of 100. So if you're talking about it, basically you take the number, divide by 100, right? Or multiply by 100, going whichever direction you want, right? So for instance, if I have, oh, these ones are already given to you. If I have 0.25, I times it by 100 and you get 25%. Now, here's the deal. You could teach them how to do that with a calculator, but remember, we're trying to get them to use brains, right? So you think about it, if you're multiplying by 100, there's two zeros. So you're going to move it 2 decimal places to the right. So on this 0.25, bang, we move it 2 to the right. We end up with our 25%. Okay. Look at this one, 0.33333333, right? Well, that would be 33 because it's 2 decimals over 0.3333. Well, okay, that's garbage. Remember, that's one of those weird ones. What was decimal 03 repeater as a fraction? Do you remember?
1/3.
So technically what you could do is instead of writing 33.333, you could write 33 and 1/3%. Makes way more sense.
No,
Okay.
it doesn't.
Sorry, what was that?
I'm even more confused now.
For which one?
For the 1/3. 33.1/3%.
Here, let me give me a sec.
Heard of that.
Oh, that, you know what? I don't have to stop sharing screen. I can just do that. I got to start doing that. That's way faster. Hang on. Where's my, oops, sorry, I need my pen. So 0.3 repeater is 1/3, right? Just like 0.6 repeater is 2/3, right? So when we have 0.33333, and it just keeps going on, right? If we were to write that as a percentage, right? You're basically timesing it by 100. So that's going to move the decimal places 2 over. So you end up with what? 33.3333 ... percent. Well, that's really hard for a lot of people to understand. So what could happen is this part here this 0.33333 repeater is technically what fraction? It's 1/3, isn't it? So we can write, instead of this 33.33 repeater, we can write 33 and 1/3%, like that.
Okay, I never knew we could for
Yeah.
percentage.
Yeah, and it's just a more practical way of writing it, because a lot of kids will write like 0.333 or 0.666. Yeah, right. I find a better way. Okay. Let's go back to here. Okay, so the other one, 1.255. Well, again, your times going by 100, so you're moving it 2 decimals. So you still move it 2 decimals, you get 125.5%. Well, we can't give more than 100%. Well, of course you can. In math, you can give way more than 100%. Okay, 0.0035, you move it 2, right? Because timesing at 100. So you end up with 0.35, but proper math is better as you write 0.35%. Okay, percents don't have to be between 1 and 100. They can be over 100 and they can be less than 1, right? It's not a big deal. So that is going from decimals to percents. Could we go the other way? Could we go from percents to decimals? Yes, we can. But instead of multiplying by 100, we divide by 100. So we move it 2 decimals to the left. So 40% divided by 100. We're going to move it there. So, and again, good math, we do 0.40. We converted it to a decimal. 12%, you move it 2 to the left. So you end up with 0.12. 127%, you can move it 2 to the left, so you get 1.27. These ones here, 0.5, always screw people up because it's, oh, wait, it's already in decimal form. No. It's in percent form. We need to convert it to a decimal, which means no percent sign. So we divide by 100 or move it 2 to the left. So we end up with 0.005, right? The biggest thing people will say to you is, no, that one's already in decimal. No, it's in percent because there's a percent symbol there. We need to convert it to a decimal. Okay, now, how do you change a fraction to a percent? How do you do this?
Proportional reasoning. 37 over
Calculator.
40 equals x over 100.
Okay, so you could do it the way they do it, right? Which is change it to a decimal or proportional reasoning. Okay, so here, let me show you, right? They go 37 over 40 equals r over 100, right? And then you cross multiply, you get your decimal, or sorry, you cross multiply and you get your answer, right? To me, that's kind of a complicated way of doing it. And you end up with your answer of 92.5%. What is a much simpler way of doing this?
Well, the way I would do it, I would just do it the long division way.
Okay, so you would take 37 and divide by 40, do long division, get your
Yeah.
decimal, and then
Convert it to a percent.
yeah, just times it by 100, right? Which would mean 2 decimal places.
Yeah.
Really, both ways are the same way of getting them, right? You'll get the same answer no matter how you do it. If you're doing with this calculator, the fastest way is just to take the numerator divided by the denominator, hit equals times 100. That's the fast way, super fast way, right? Now, the reason we sometimes do it this way, and I think that was Eric, was that you, Eric, that was telling me that? I can't remember.
Yep.
Yeah, that was you. Sometimes we do it this way because this works really well for students to see the proportion method, right? 37 over 40 is what we're trying to find out of 100. We're trying to make 2 equal proportions. So that's why we set this bottom equal to 100. It's both ways work really well. Okay, so let's look at an example here. So Sue Ling scored 92 on her last test. If she got 23 questions right, how many problems were on the test? Well, this is kind of hard to do unless you're set it up as a proportion. So you can still do it this way, right? So let n equal the total number of problems on the test. So we say 92% of some number, we don't know what the number is, equals 23. Okay, well, that's a little hard to look at because a lot of people would look at that and they'll go, I don't understand that. You're trying to send up algebra. Okay, so then you convert 92% to a decimal. So 92, that would be 0.92n equals 23. And then how do you get rid of the 0.93? You divide both sides by it and you end up with 25. Okay. So there was 25 questions on the test. She got 93, she got 23 of them correct. She ended up with 92%. 25 questions, she got 23 right. Now, Eric, the way Eric was talking about is you could set it up as a proportion and it might make more sense to you. She got 92 out of 100, right? See how we set it up as 92 over 100? And that equals the 23 out of, we don't know how many total test scores there were. So, oh, okay, there's our unknown. And if you cross multiply, you end up with 92x and 100 times 23. And if then you divide by 92, you're going to end up with the exact same answer. So it doesn't matter to me which way you do it. You have to pick the way that you understand the most, right? This one is the word problem way. When you see of, it's multiplication. This one is the proportion way. Either way works fine. Oh, we're running out of time. Okay. Okay, we got 3 last slides here. When we're talking about percentage, one of the main things to deal with percentage is interest, whether it's interest on a loan or interest on an investment. So there is a formula. It's called the compound interest formula. You don't have to memorize this. It is on your formula sheet. So here it is here. So the value of the investment P, right? That's the principal invested, is 1 plus R, and R is the rate divided by 100. And so N here is the number of times a year it's compounded. So we'll do an example, don't worry. So for instance, if it says it's compounded annually, N would be 1. Compounded monthly, N would be 12. Compounded daily, N would be 365. And T is the number of years. So it's the compound interest formula. So here's a real life example with compound interest. Let's take a look at this. Credit card companies charge you interest at compounded, whatever they pick. A lot of them are daily now, but compounded monthly on unpaid balances. Suppose your card was maxed out and your credit limit's $10,000 and that you were unable to make payments for 2 years. Aside from the penalties, how much debt would you owe? Okay. So what we have here is we have a bunch of it, and it's a word problem again. I know you guys love word problems. So for starters, let's break this down. The 18% is going to be your interest rate. Your 10,000 is going to be your principal. You're going to do this for 2 years, so T is 2. Now, here's the hard one. What is the N? What is the compounding? What's N?
12.
It's 12. Okay. So look at the last page here. So principal is 10,000. The rate is 18. N is 12. T is 2. Right? So then all you do is you plug that into the formula. So here it is. I'm going to put the formula up and we're going to plug it in. Okay. Now, this is where you have to understand bed mass. Brackets, exponents, division, multiplication, addition, subtraction. The order of operations. What are you going to do first?
The stuff in the brackets.
Okay, all the stuff in the brackets, correct. And within the brackets, what part is going to be done first?
Multiplication.
The multiplication and division, right? And then you'll add the 1 to it. Okay. Now, here's the cool thing. Grab your calculator. You can do this with your calculator in one shot. I'm going to teach you how to do this. So here, I'll do it with you too. Where's my calculator? There it is. Calculator. There we go. So the first thing we're going to do, 18 divided by, now what, you don't need a calculator for this one, 100 times 12. Well, that's going to be 12 with 2 zeros after it, right? So you'd have the 18 in there. Now do 18 divided by 1200. Hit equals. You should get decimal 0.15. So hopefully you got that. So that was 18 divided by 1200. Now we have to add 1 to it because we're still in the brackets. So go plus 1, hit equals. You should get 1 decimal 0.15.
When did you do the exponent? After brackets?
I'm getting to that one. Okay, So now what we did the 18 divided by 1200, hit equals, and then plus 1, hit equals. Now, this exponent up here is 2 times 12, which is 24. Now, you got to get that on your calculator. Now, your calculator has one of a couple buttons. It's either going to have a Y to the X button, or it's going to have a little hat, like a little hat. Look at your calculator and find out which one it is. Mine's the hat button. Most of you, if you have a regular calculator or even on, I think on your phone, is going to be a Y to the X button. You're going to press that next. And what that's going to do is that's going to allow us to put the exponent in. So now you're going to put in, you put that little hat or that little Y to the X. You're going to type in 24 and then hit equals. And if you don't get this, I'll help you once we do some questions here. You should have got like 1.4295 and a whole bunch of change. Okay. If you didn't get that, I'll help you in a sec. And then the last thing you do is multiply that by 10,000. And you should get 14,295 decimal, this is money, 03 if you round properly. Okay. If you did not get that, I will help you in a second with that one. Okay. In the meantime, that's the end of the compound interest one. I will put up 7.3 and 7.4. You can start working on some of those. You'll start working on some of those, and then I'll help those who did not get that. You just basically have to know your calculator, but I can show you that pretty easily. Okay, let me flip the thing here. Oops, let me flip it to the right one. Oh, there it is.
I have
there.
a question.
Oh, yeah.
When we do the assignments, do you like, you're showing us an easy way to do it with the calculator. Do you mind if we not show our work if we do use the calculator, or would you want us to show our work
Here's what I want
how
you
we
to do.
got the final answer?
Yeah, the final answer. So on the assignment, I want you to show the work, but here's the deal. Can you use your calculator to check to see if you got it right or not?
Yeah.
Easily. But like here, so there's another question. So on the test that we do eventually, you're going to have questions like this. Well, you can't show your work. You just got to be able to do it with your calculator or do it manually and pick the right answer. That's fine.
Okay.
Okay. Okay. So, oh, and then, so there's your numbers there, like we did. So 1 point, get the answers. Okay, here it is there, 7374. Okay, now, who did not get that with their calculator? Who needs help? I will gladly help you, unless everybody got it. Hopefully nobody's, hopefully if you didn't get it, you can let me know. I'm not, it's just a matter of getting, oh, there's chat here, hang on. Oh, yes, Alice, that would help if you got a calculator. Yeah. I think it'll check on your phone. If you turn your phone sideways, I think you get the Y to the X button. Here, let me look at mine. Give me a sec here. Calculator. See, the regular calculator doesn't have it, but when you turn it sideways,
It works. Sometimes my phone is stupid.
Yeah, I believe that. Phones can be tricky sometimes. Where the heck is it? Oh, maybe
There's
it's not even
also a neat free app called Desmo's Scientific Calculator that you can download.
I use Desmos every day there, Lacey.
It's fantastic. And you can get an app on your phone. So if you don't have it, then it gives you a lot more options.
Yeah, you have to understand how that app works a bit though, like the program works a bit. But I mean, for most
used it in my last math class a lot. So it's, I'm pretty comfortable with it.
You know what, Alice, I don't see the Y to the X button on here at all. Yeah, you might be hooped on there. Oh, there it is, X to the Y. Yeah, it's on there.
So do we use the X to the Y or the X to the 3 or the E to the
Well, no. So squares and cubes are really common. That's why this X squared and X cubed is on there. But you want to do X, you want to put Y to the 24. So you got to use that X to the Y button. Okay. So do you have your calculator turned sideways like that?
Yes, I do, but I got a weird number.
Okay, well, we're gonna go through. Hang on. We're gonna go through it. So type in 18 divided by 1200. Hit equals. You should get 0.015.
Yes.
Now add 1 to that, and then hit equals. You get 1.015.
Okay.
Now press the X to the Y button. and type in 24 and then hit equals. You get like 1.4295 like that. Did you get that?
Yes, okay.
Now times that, now multiply that by 10,000
Mm-hmm,
and you'll get your correct number.
thanks.
You're very welcome.
I forgot the one, that was my mistake.
Nadine, yeah, X to the Y, yeah. Everyone's slightly different. The other one is like a little hat. You'll see that like my calculator that I use all the time, this big beast here, it's a little hat. I think it's right here, the little hat. If you see what they look like for those that are at home. Okay, we're just doing questions. I'm just gonna run again. I'll be right back. So if you have a question, just hold on a sec.
have a question.
Yes, Alice?
On page 338, and question 7, section 7.1.
338, you said?
Yes.
And which question?
I don't know what question 20 means.
Oh, okay. A fraction whose decimal repeats with a length of 4 would be, for instance, 7.1234, 1234, 1234. That has a length of 4 because that's the repetition. Just write a decimal down. You don't need to switch it to a fraction. I wouldn't ask you that anyway. So,
Okay.
so it could any number. So it could be like decimal 2256, 2256, 2256. That's a repeating of 4. Like the one above it, I says a repeating of 3 would be like decimal 224, 224, 224, because that has a repetition of 3.
Okay.
I have a question on the assignment.
Assignment 3?
Yeah.
Yeah, hang on a sec. Sorry. I had the book open. I don't have assignment 3 open. Oh, assignment 3. Okay, which one?
On question 4.
So in that one, you just got to pick which ones are the same. So there's 4 figures. So like look at 1 and 2. Are they the same?
Yeah.
Yeah, because one's like 1 over 4 and one's 2 out of 8, right? But are they equivalent? So you would put like a 1 and a 2. That would be one of your answers, right? Because figure 1, figure 2.
Okay.
So just
Thank you.
list off 4 different pairs. That's all you're doing is list off 4 different pairs.
Okay.
I have a question too.
Yep.
I don't remember if you did it today, but question 28 on the same page, 338. Did you show us a trick? I don't remember.
No, these ones are just writing the decimals. So basically take the numerator divided by the denominator. You could either do it by doing long division or just grab your calculator and go 5 divided by 9 and then just write it out.
Okay. Because it said I shouldn't use a calculator. Oh,
It says without doing any calculation or most doing mental math. I mean, I would just write, if I'm going to ask you, I'm just going to ask you to change a fraction to a decimal. That's what I'm going to ask you. Some of the questions in the textbook go further than we need to in what we're talking about. So we'll keep working and we'll take the last 5 minutes. And I just want to show you a potential game that you guys could use in your classroom. That's really, really, I think it's fun. When I played it with it's one of the games I've played in this class when we actually used to have class in person, and students really liked it. But we'll do that in the last 5 minutes.
I have a question.
Which one?
On page 344, question 3. Could you show me again how to multiply?
Question 3?
Yes. I'm still confused with decimals.
I know, I got you. 3A, you want 3A? Is that the one? 37.1 times 4.7. Give me a sec here. Okay, so the easiest way, just ignore the decimals. So put 371 and 47 on the bottom like this, because you're multiplying, right?
Mm-hmm.
So then what we do is we start with the 7, right? 7 times 1, 7 times 7 is 49, carry the 4, 21 and 4 is 25, right?
Mm-hmm.
Then we deal with the 4, and because we're in this column here, we start here. So 4 times 1 is 4, 4 times 7 is 28, carry the 2, 3 times 4 is 12, and the 2 is 14. Okay?
Mm-hmm.
Then you add them like this is the long way for doing multiplication, right? So 7, 3, 14, 7, 1, right? Okay.
Mhm.
Now we got to deal with the decimals. So let's go back up the decimals. How many decimal spots here?
1,
How many decimal spots here?
1.
So how many do we have to add at the bottom?
Is it 2?
Right there.
Okay.
So you end up with 174.37, like that.
Okay. Thanks.
Does that make sense?
Mm-hmm.
And the nice thing about it is, I mean, you can do it manually, but you can also check the answer with your calculator real quick, right? It's nice to know sometimes if you're doing it right just by a quick calculation, right?
Yes, I could see I was out with my calculation.
There you go. Okay, last 5 minutes before the end of class. Wow, did we lose a bunch of people? These people don't like staying to the end. It makes me sad. Now I'm gonna go cry. Actually, no, I'm
Yeah, why
not.
don't you take some supper?
Okay, so what we're gonna do is we're gonna play, this is what you would normally play as a game. So let's go get off of this one here. Oops. Go to this. Course materials. Day 11. So what it is there's a couple websites on here. There's what do we want here? Base 10 blocks. This website here, Base 10 blocks. We've been here before, I think. You remember this was the one where you can throw all the junk on here? We used this, I think it was last week or the week before, because we did it to everything into the ones, hundreds, and thousands. Okay. Now we can use this, but we changed the top here a bit. So here, let me undo this thing. So what it is there's a game, and let me go back to the game just so you can see which one I'm talking about here. Nice, Justin. That was a funny comment. Okay. Where the heck is it? Sorry, Race to 1. It's a really, really fun game. And what you do is, if you ever have this in class, what it is you're trying to get to 1. Okay. But to do that, you're using the flats, the rods, or the strips, and the cubes. Okay. So what you would do is you would divide the group into 3, right? You could do it in 2, you could do it in 4, doesn't matter. And then what's going to happen is you would use this place value mat, this one right here. Okay. So what you do is you roll a dice, and you have a 6-sided die, just a regular 6-sided die. And you roll the dice, and if you ended up with 4, what you do is you go to the hundredths and you put in 4 little guys. So what you could do is you could do this. We're going to do it virtually because obviously we don't have access to, we don't have access to you guys being here. Is this the one I want? Hang on. No, oops, sorry, went to the wrong one. Sorry, my bad. Yeah, website here. There it is. Okay. Now this one's wrong at the top, but for instance, pretend this is the hundredths, right? The right-hand column. the tenths, and this would be your 1 here, right? So your decimal would be right here if you were to do this. So we had this as a decimal. This would be your decimal. Here, let's fix this. What did we say this is? This is a hundredths, right? Woo. Trying to write with a mouse is just ridiculous. This would be tenths. And this would be 1. Okay. So it's kind of cool. What you do is you take turns, like I said, you take turns rolling. And let's say you rolled a 4. So what you do is then you put 4 here, right? Bang, bang, bang. Okay, the next kid rolls the dice and they get a 6. So then on their sheet, they would put a 6, right? And the next kid rolls a 2 and they would put 2 there. So now we're back to the beginning again. So let's say I roll a 3. So 1, 2, 3. Okay, so far nothing's really happening. The start of the game's kind of boring. So then the second person rolls, they add their dots. The third person rolls, they add their dots. Now it gets to my turn again, and I roll a 6. So I can add 6 dots, right? So 1, 2, 3, 4, 5, 6. So now, are there more than 10 dots here? Yeah. So what can we do an exchange? Can I take 10 of these dots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There they are. I can take all of those and replace it with one of those in there, right? Because all I'm doing is I'm exchanging them, right? So if I wanted to, here, let's get rid of these guys now because these are all gone. Right? Oops. Right? So you just keep rolling along on this. Okay? So then what happens is you keep rolling and rolling and rolling. And basically you're going to fill this up and then you're going to slowly start to fill up this strip here. So let's say we play it and it takes quite a while to do, right? We're talking probably 10, 15 minutes to do it. And what happens is, let's say you finally get a whole stack in here, right? A whole stack. 1, 2. So what's that? There's 9, right? Hang on a sec. Was that 5? That's 8. So let's say you get to 9. Then all of a sudden, in this column here, let me put in enough here. You roll exactly enough. What's that? 5. Okay, so now that was your last roll. So then all of a sudden you can take all of these ones here in this one, right? Get rid of them, right? They're all gone. Bang, bang, bang. And you exchange them with 1 strip. Oh, sorry, I'm trying to get rid of them real quick here. You get rid of those, right? And then you put your strip here. Now, do I have 10 strips now? So I could replace all of those with one of those ones, which is now a 1. That's why the game is called, what was the game called again? Race to 1. The object of the game is to get to 1. So you just keep rolling the dice and putting in numbers. And it really works really well because they're working on counting in tens, but they're doing it in fractional form, right? They're doing it as hundredths and tenths. So without even knowing it, they're learning about those decimal places. And then what you could do, this is kind of cool, and this is a really neat variation. Right here, it says, after placing the cubes on the mat, the players have to state the decimal number. Right? So if they're doing a question like this, let's go back to it again, wherever it was, website here. For instance, whatever they have, it's going to come up as a fresh one. So let's say they had this one, right? And they would have to state what the decimal was. So then they would state 0.23, and they would write it down and they would say it. So they're seeing it visually, as in playing the game. They're saying it verbally, like auditory wise, and then they're writing it down numerically. So they're getting fractional form as a really, really good way, 3 different ways. Okay. So when you get a chance, please, by all means, it'll stay on here forever. The race to 1 rules, you can print it off. They're right there. Yeah. And if you want the place value mat, you can print that off there. They're just PDFs. Use that in your classroom. They're fun. It's a really fun game. You got to trust me on that. Okay. And I apologize. I went 2 minutes over. I don't like to go over late. Now, if I could just get you all to start on time too, that would be nice. Some of you sign in after 5, but that's not a big deal.
There's a lot of, I know, a race to 100, a race to a 10. They're really fun.
They're all really good games. They all have a really good base on these ones. Okay, so what was that? Hang on, let me see somebody. Oh yeah, Justin, yeah, go, yeah. Okay, so that's the end of it. Just a reminder, Thursday assignment number 3 is due. Some of you had already given me their assignments. They got both those people got really good marks, but I can't send them back just yet because not everybody does. And I will give you updates of your total mark overall on Friday. So I'll include what you got on the midterm, and then I'll give you an overall mark so you have an idea of what you're sitting at. But most people did really well on the midterm. I was quite impressed. That's it.
Okay, see you tomorrow.
Have a good one. Stay out of trouble. I will talk to you tomorrow. I will stay online in a second.